Ladies and gentlemen, prepare yourself for a bittersweet news. Today, we delve into the world of data science where a groundbreaking feature has just been unleashed by none other than OpenAI. What have you done, OpenAI? Should I, as a data scientist, be overjoyed or perhaps feel a tinge of sorrow? My friends, OpenAI has gifted us with a powerful tool called Code Interpreter, a marvel that, dare I say, can perform nearly every damn task we used to labor over as data analysts. Picture this, a time when we, as data scientists, painstakingly delved into the depths of our data, tirelessly cleaning, organizing, and finding patterns. Oh, the monotonous routines we faced, day in and day out. But now, dear friends, OpenAI's Code Interpreter has arrived to revolutionize our field. Let's take a moment and reflect upon the memories we forged as data analysts, the challenges we overcame, the victories we celebrated. It is only natural to feel a mix of emotion elated from the newfound freedom and a twinge of melancholy for the routines that once shaped our professional identities. Rest in peace, data analysts. On to the new era then, shall we? Alright, get ready. Let's see what is this code interpreter and how to use it. So the Code Interpreter is basically a ChatGPT plugin by OpenAI that pushes the boundaries of what's possible with AI by enabling data analytics, image conversions, code editing, and much more. All these tasks can now be performed through an easy text interface. It is important to note that this is only available to people who have GPT-4 and plus access. So in order to enable this, what you have to do is click on your profile and go to settings. And here, go here and you have plugins and code interpreter. So enable both. That's good to have plugins and code interpreter, and let's get started. Now you have code interpreter. Now in order to use this, what you have to do is you have to click on GPT-4 and there you have it, code interpreter, and you will get the plus symbol on your text area. Now I'm going to do it on a real project, so let me choose a file and let's start with a real project. Okay, let me decide what to choose. I think I'll choose this file. This is basically a file that I have analyzed for hypothesis testing. So let's see if GPT could do the same. Alright, it's time to prompt. Alright, a little bit intro about the file. Basically the file has 3 columns, top speed, mileage, and the car models. And what we have to do is, the engineering team claims that they have a particular mileage and a particular top speed. So what we have to do is we have to validate their claims. Alright, here we go. I think this should be good. So the engineer claims that for Rocinante 66, the mileage is greater than or equal to 22 and the top speed is more than 140, and Marengo 32, it's going to be more than 15 and the top speed is more than 210. This is quite a common file that everybody uses for hypothesis testing. This is called random motors. You can probably Google it out. Let's see what do we have. We have car number, mileage, top speed, and model. So car number is basically how much cars they have tested, and all the other I've already explained. And EDA is happening. So let's see what it brings out as part of the EDA. Hey, before that, we can even look at the codes. So let's look at the code. Here we can see that it has imported pandas and it is reading the file and it's printing the head out. And it's probably describing that to us. Alright, typically the next step is a histogram. Yes, there we have it, the histogram, and we probably will want to find the threshold values that we told that the engineers have claimed, and we can actually test that out. If the number of cars that are below that and above that, yes, that's what we have. Alright, let's summarize the inference from the distribution. Okay, the inference is okay, but I still need the percentage of cars, or probably something like A statistical test, hypothesis test is what I was expecting. Let's see. Okay, so it's trying to do a percentage test. Well, that is fine. That is another good thing to have. We can simply say a heuristic like, okay, how much percentage of cars is more or less, how much exceeds or meets the expectation. That's a good thing. So let's say at least half of the car or more than half of the cars are meeting the expectations. We can say, all right, so this is the percentage of cars that meets the expectation. So that's what it's trying to do. That's okay. And it is also trying to take some inference out of it. So significant proportion of the cars in both models do not meet the claims of the engineer, right? So that's what it's trying to say. Alright, what I'm going to do is I'm going to paste this hypothesis test value because I want a hypothesis testing. So let's ask it to perform a hypothesis testing at a 95% confidence interval for both the cars. And here we go. Alright, one sample t-test, that's good. So it knows that it needs to do a one sample t-test, and it's formulating, I guess, the null and the alternate hypothesis. Okay, the null hypothesis for Rocinante 36, mileage and top speed, and Marengo 36, Marengo 32, both the null and the alternate hypothesis is now formulated. Alright, that means that it's show time for the test. So it's actually running the test. Alright, it's over. So here are the summaries of one sample t-test for each cars. Okay, so finally we have the summary that we wanted. The p-value for Rocinante 36 is approximately 0.041, which is less than 0.05. So we reject the null hypothesis. The true mileage is actually less, is what it means. And for the top speed, again, it's greater than 0.05. So we don't have enough evidence to support that the true mean top speed is less than 140. So we don't have enough evidence is the right way to put it. So I am impressed. And mileage 0.933, again greater than 0.05, no evidence to reject null. Again, the top speed is 0.814, which is greater than 0.05, so again no evidence to say that it is actually less than 210 kilometers per hour. And the total summary is the hypothesis tests suggest that the claim about the mileage of Rocinante 36 doesn't hold. However, there is no evidence for all the other three things. So the only thing that has failed our hypothesis test is the mileage testing of Rocinante 36. So in theory, or in simple words, mileage of Rocinante 36, the claim is wrong. That's all we have. Alright, that brings us to the last thing that we usually ask in any hypothesis test, like which error is more expensive. So if in this particular case, if I have to recall or refund all the customers who has already bought the car which does not hold its claims to be true, which one is more costly, which one is going to cost me really high? So let's see what a GPT has, or let's see what code interpreter has to this question. So we have both the type 1 and the type 2 error, I guess, in this particular case. Yes. So it clearly defines what is a type 1 error. It means when the cars do not meet the performance specification when they actually do, right? When we say that they actually meet the expectations, and when we say that no, it doesn't, that's type 1. And the opposite is type 2, which is exactly the problem. When we say that it meets the specification, but when they actually do not, that's type 2. So that is the most expensive problem, because that's what causes the company to probably recall the car. So I think it got pretty much everything, and Random Motors would want to minimize type 2 errors. That's correct. And they might want to choose a higher level of statistical significance to ensure they're not missing any instances where the cars actually do not meet the performance specification. That's a good suggestion. Alright, let's quickly recap what are the things that we saw today, and I guess most of the things that we saw today were amazing, all because or all thanks to Code Interpreter plugin that OpenAI has released. We saw how to use the plugin, and you can only use it in GPT-4 and you have to be a Plus member. And the other thing that we saw was how we can actually use it and all the opportunity that it has in store for us. And the other thing that we saw was hypothesis testing and p-value, and where hypothesis testing is actually useful and how p-value makes sense to an hypothesis test. And the final thing that we saw were errors, and there were two types of errors, type 1 and type 2, where we clearly defined what is type 1 and what is type 2 errors. And in our case, type 2 errors would have been more costlier because we would have ended up recalling all our cars. So that's it from this time, and it's Giridhar Chandrasekharan, your ever passionate data scientist, signing off.